Hi. The purpose of this video is to summarize, quickly review various methods of factoring, and essentially how to strategize, how to choose which method to use when. It looks like a lot of methods, but in fact, if you look carefully, these are not cases of factoring. These two are, in fact, cases when expression is not factorable. I included it here just to complete my flowchart, but I'm going to cross it out for now. So you can see that there are essentially only four methods. Perfect square trinomial, general trinomial, difference of two squares, and greatest common factor, which works both for trinomials and binomials. Speaking of which, this is the very first decision you need to make. Is your expression has a trinomial or binomial? Once you're clear with this, let's look at each specific group. If you're extremely lucky, then you have this first case, perfect square trinomial. Perfect doesn't come often, so yes, it's a lucky case. How can you suspect it's a perfect square trinomial? You're looking at the first term, it's a perfect square, the last term is a perfect square, and it makes you optimistic. So you're thinking, okay, the first term is a square of 2x. The last term is a square of 5. So I'm very hopeful that this will be a square of the binomial. It will be a difference because of this little minus here. In order for this to be true, I must have double product in the middle. So let's check. 2x times 5, 10x, double, 20x. And it will be a minus. So yes, it's perfect. I got it. So this is my answer. 2x minus 5 squared. Again, for this to work, all terms must be very specific. Let's look at the next example. We have 4x squared and 25, all the same. But it won't be a perfect square trinomial, as you know, because 25 is not a double product. We can still factor it using a general trinomial technique. So let's see. As always, if you hope to factor using general trinomial method, we prepare. We write two pairs of parentheses, and we are thinking, okay, in order to get 4x squared in the front, you can either get 4x times x, or you can get 2x and 2x. You already see why it's less lucky case, because you have to consider several cases. Let's start with this one, actually. So 25 we can get two ways. We can get 5 and 5, but we know it's not the case, because then we would be back to perfect square case, and it's not. So the only way it would be 25 and 1. It doesn't matter which one goes where, because both parentheses start with 2x. We know it must be a minus in each, because 25 is positive. So let's see what happens. Minus, that's a lot, minus 50x and minus 2x. No, it's not good. So this is out of question. So then let's look at another option. We can have several choices, unfortunately, for 25. It can be either 5 and 5, or it can be 25 and 1. And to make matters worse, 25 and 1 can be swapped around, because now it matters. So let's see what happens. In this case, minus 5x in the middle, minus 20x. Oh, we are lucky. So that gives us a correct factorization. If it didn't work, we would have to check this one. And if this didn't work, we would have to swap them around and check it again. But in our case, we already know the answer. So it's 4x minus 5, x minus 5. Okay. At this point, you already understand why perfect square trinomial is preferable, because it's much less work. So try the next example on your own. It's not much different from the other one. I just wanted to demonstrate that for perfect square to work, everything should match. The first and the last term should be squares, and the middle term should be a double product. So in this example, you see squares are okay, but double product is not good. Here we still have the same 20x, but it cannot be a perfect square trinomial because 21 is not perfect square. Anyway, do this problem on your own. And in this next example, no matter how much you try, it just won't work. So it's not factorable. I just wanted to show you all possible cases. All right, so I'm going to skip this for now, greatest common factor, and let's switch to binomial. The only special situation when quadratic binomial is factorable if it's a difference of two squares, square minus square. You know this case very well. We don't even need to do special writing for this. We can just write the answer: 2x minus 5, 2x plus 5. Just one quick note. Just recognizing and it's a difference of the squares allows you to skip all this process we had to, all these trial and errors we are trying to do here. So it's definitely beneficial. What's important to remember that it must be a difference to be factorable. If it's a sum of squares, you cannot factor it. Some people try this. Oh, it's a sum, so let's just do 4x plus 5, 2x plus 5 times 2x plus 5. No, it's not going to work because that's a perfect square and you will end up with a double product in the middle. That's it. There are no more options. You cannot factor this. Just remember. Finally, the greatest common factor, factoring out common factor, is a universal technique. It's not specific for trinomial or binomials. It's not specific for quadratics. You can factor out common factor from any expression if it has it. So let's just look at a couple examples here. Common factor is 4. Once we factor it out, it's x squared minus 5x plus 6. And now it becomes much more transparent and we can factor it quickly and we can see that it's x minus 3x minus 2, right? Right. Without factoring out 4, this would be not as obvious. Finally, in the last example, we can still factor out common factor from a binomial. If you look carefully, it's 4 is a common factor and x is a common factor. So once we take it out, it's x minus 5, and then we are done, we finished. In conclusion, first question you ask yourself, trinomial or binomial? If it's a binomial, you essentially have only two options. Either it's a difference of two squares or there is a common factor. If it's a trinomial, you have essentially two cases. If it's a general trinomial or it's a perfect square trinomial. And greatest common factor can help you see what's going on inside. So this method should always go first if possible. Whenever you look at something to factor, this should be the very first thing to ask. Can I factor out something? And then you will see structure better. Good luck.